So we're just going to go through.
Maybe intermediate.
I will in the 2 slides from now. Planning on it. So we're going to talk about just an introduction to infrastructure as code in general. I'm going to go over just a bit of an agenda. So I'm going to talk about who I am, what infrastructure as code is, what the benefits are. I'm going to do an overview of Terraform. I'm going to talk about my experience running Terraform at scale. So this is going to be regarding GCP. That was a very interesting experience, and share that part. We're going to do a little bit of a demo of actually launching infrastructure in Terraform. So that's going to be done with AWS just to give people an overview that don't understand what Terraform looks like or how it's used. I'm going to talk about the state. I'm going to talk about modules, and then we're going to wrap it up with a CI workflow that's going to be done in Jenkins. So to get a better understanding of how you can use Terraform in CI with other people if you're more than one developer on the team, of course. And then any questions. And we're going to be watching boxes, just like the Silicon Valley episode there. People have seen that. It's a good one. Cool. So who am I? My name is Alex. I am the principal consultant at Scalar Software, where we just do DevOps consulting. And previously, I was a tech lead at TELUS, and that's where I ran the cloud team, and that's where a lot of that kind of enterprise Terraform comes from, and when I ran Terraform in the enterprise and at scale to see, pretty interesting stuff. I'll get to it. So just a brief overview for people who don't know what infrastructure as code is. It's pretty simple. You just define your infrastructure within a configuration file, and then a tool is going to launch the infrastructure based on those configuration files. So pretty simple stuff. You have a file, you have what your configuration looks like, what your infrastructure looks like within those files, and then the tool is going to launch what that looks like. So pretty simple. So what are the main benefits of infrastructure as code? And I think the biggest one is version control and Git. So being able to actually store your infrastructure and source control is huge. But it definitely puts you ahead. It also prevents what I call infrastructure snowflakes, where, you've probably all dealt with this, where you worked at a place, everyone kind of just has owner access to a cloud environment. You have like instances from 2013, you don't know what the hell they do. So that's always interesting.
If you pay for it, eventually you realize.
Oh, you'd notice. The worst part is when that employee has departed like 3 years ago, known as the key, and then you gotta like figure out what this thing is doing, hopefully not running any sort of production stuff. Fortunately, that happened a few times at places I've worked. And also just that collaboration aspect of it. So like being able to create pull requests and then have people review your infrastructure is pretty huge. It also just prevents mistakes from happening. So being able to collaborate with other team members, get insights, whatever. And because it's in version control, CI/CD, being able to run your infrastructure in a pipeline is huge, especially when you got 3 developers that are creating infrastructure, or you work in a large organization, and you can collaborate that way through CI. And I'll demo that later with Jenkins, what that looks like with pull requests. Pretty neat stuff. Cool. So what exactly is Terraform? Pretty simple. Terraform is just an infrastructure as code tool. You have these things, .tf extension files that you just define your infrastructure in. They're called resources. Terraform will take that, and Terraform will then launch that infrastructure, and then there will be a corresponding state file that gets created. So what the state file is, it's just tracks what your configuration looks like. So if someone wants to make a change in the future, the infrastructure that was launched is tracked by that state. So if you want to change your port or whatever, it looks at that state and makes sure that all that is. So it's very deterministic. So if you launch something with Terraform and you rerun that Terraform command, you're going to have the same output every time after it's created. So that's great because everything's tracked in that state. And I'll talk about like remote states and how that looks like when you start doing collaboration with other developers and you want to launch infrastructure and make changes to infrastructure. So why Terraform? That's a good question. So a lot of cloud providers have their own infrastructure as code tools. Obviously, Terraform is not the only one. The reason I chose Terraform specifically for what I do is because I work with more than one cloud provider. And when you work with more than one cloud provider, you want to learn specifically, like GCP has this weird infrastructure as code library, and then Amazon has their own. If you use Terraform, it's the same for every cloud provider. So once you know Terraform, that's kind of it. You can figure out how to launch infrastructure. For example, I mostly work with AWS. When I wanted to launch infrastructure in GCP, it was pretty easy to figure out. I didn't really even need to go to the GCP UI. I was able to launch resources. It's so similar between GCP and AWS. And if you're using all the cloud, there's even support for that. So there's support for every kind of major cloud provider, which is pretty crazy. So if you're using Azure, if you're using GCP, if you're using AWS obviously the big ones, and then there's, Don was mentioning someone who's doing bare metal stuff, like that's all possible. So it gives you a lot of options in terms of what you want to do and where you want to launch it. So I'll be talking more about good use cases around Terraform. So my experience with Google Cloud. So this is an interesting one. When I worked at TELUS, we wanted to use the cloud. More specifically, we wanted to use it properly. Originally in AWS, it didn't really work so well. A lot of it was just a giant snowflake built by people who haven't been there in years. So when we did a big overhaul, we had a good use case for GCP. We were using Kubernetes at the time, specifically, and we wanted to look at using GKE. And so then when we started evaluating GCP, we wanted a way to basically not have snowflakes everywhere. So Terraform was good for that. I've had experience with it before. We wanted to create a way for developers to be enabled, but also to create kind of those guardrails to prevent people from doing crazy stuff and launching infrastructure all over the place that isn't accounted for. And so that's a pretty big thing. And so what we started doing is we started looking at Terraform, we started creating modules. Modules just like a collection of resources. You can abstract away a lot of settings within Terraform, so users aren't confused by a lot of that stuff. They can just fill in 3 values as opposed to filling in a whole bunch more if you abstract the module. Think of that kind of as a function. And what we did is we created this project module, and what that had set. So GCP is a little different. I don't know how many people are familiar with it, but you have things that are called projects, and within those projects you have your infrastructure, as opposed to Amazon's a bit different. So everything's kind of namespaced in GCP. So what we did was we created this project module, and within that we had all the billing linked, we had all the APIs that had to be enabled because GCP requires that. We had basically all the default settings that we needed for this to work properly. And then we gave it to a developer, like, hey, here's this project module. You can take this, and in a few lines of code, you can have your GCP project, and all your permissions are there. One nice thing was, by default, my entire team had access to every project because we would just grant ourselves owner access for within the module, so no one could ever remove us from it, which was nice. We had an oversight around everything that was getting created within GCP, so that was great. Every project that was created, we knew about. Developers did not have anything more than view access. So they had access to access GCP through the UI, but if they wanted to launch something within GCP, we didn't let them, just because they didn't have that permission. And the reason for that is because we wanted everything to be within Git and stored in GitHub and run through pipelines and set up in a way like that, so we know everything that exists. We could have reusability among different projects through modules, stuff like that. So it made it a lot easier to scale when you wanted to add 100 developers, for example, and you have all this infrastructure. It's code in place and you just add 100 names. Boom, here you go. All 100 of these people have viewer access, for example. Or if you want to launch a new GKE cluster, like we have all of that abstracted away. Like it's easy to do because all of that configuration was written by the cloud people. We did run into a lot of problems, obviously, because GCP is not as mature as AWS, unfortunately. One interesting thing that we ran into was, because this was originally a mono-repo, and this is more of a Terraform practice, we started running into problems where we had like 30 pull requests in queue, builds are broken, the build takes forever to run now because you got like 5 clusters and 10 servers or whatever, so making a change takes a long time just because that state is so huge now within Terraform, you have to go through all of that. So that ends up really slowing the build down. What we ended up doing was we broke it off. So we talked to some people, we were lucky, we actually met some people from HashiCorp and Google at a conference. We were able to talk to them about kind of what's the best practice around this architecture and how does it look like, and how do other big customers that you have do this kind of Terraform configuration at scale. And it turns out not a lot of people were doing it, but we did get some good insights into basically having a single pipeline for each project. So each project would have its own pipeline, its own Terraform, its own state. Everything would be segregated. So the reason this is a benefit is if you have a state that's associated to one giant mono-repo that's a bunch of different projects, you can potentially break someone else's build. Well, you break the build in general, and because everyone's sharing that same build, you're blocking other people. So someone wants to launch a VM, they can't, build block, but if you have separate projects, you have a pipeline for each project, that doesn't prevent, you can break your own build, but that's not going to stop another developer on another team to launch infrastructure, which is great. So that's kind of how we ended up splitting that out. So each developer had, so each project typically had someone who was familiar with Terraform, who trained them up on it, so they were able to review pull requests and stuff like that. And we would provide all the modules for them to use, so they could easily just import stuff in if they needed it as they needed it. Obviously, from a security context, this becomes interesting because we didn't want to have a global key manage everything, obviously, because you can still mess with someone's project even though it's in a different repository, just because you can get that project ID. So what we did is we ended up using Vault, HashiCorp Vault. It's a centralized secret store. And what we ended up doing was we provisioned keys on demand. So every time a developer wanted to create a new project in GCP, we would issue them a credential from Vault, and this was all automated. And so that credential will only work with that specific project. And because of that, you don't have issues where you have one master key for all these projects, it's owner access in the whole org, so you don't run into those security problems. And also, if it gets leaked, that's bad news. But if you're using something like Vault, because it's dynamic, you can just rotate that credential. So that becomes easy. I don't want to get...
Was that the API key for GCP itself, or for the infrastructure you're building on GCP?
Yeah, so that specific API key will be service account, and that service account will have access to that namespace. Typically, it'll have enough permission to be able to launch namespace. But it can't access other namespaces because it's scoped to that specific project. I don't want to get too much into Vault. I can talk about that for an hour, but that's how we ended up getting that kind of security concern fixed. We ran into other issues with just how the configuration looked when you started writing a lot of it. Terraform is absolutely horrible with loops and stuff like that, so if you want to do any sort of like interpolation, it doesn't look that great. Code starts getting a little messy. Luckily, this is getting fixed in the next version. It's just Terraform version 0.12 was supposed to come out like 6 months ago. It's still in beta. It'll eventually get there, but for now, what we ended up doing is we actually, when we were at the Google Next conference, when we were talking to people from HashiCorp, we were like, use this Go templating tool, and you can basically create templates for your Terraform. And I've seen this done before with Ansible, but I just didn't like how it looked. So that was kind of the alternative. We had all this configuration in YAML. We wanted to import a whole bunch of stuff. We ended up having to use these Go templates. It looks all right, but it shouldn't be a solution. It should just exist within Terraform to be able to do this stuff a lot easier. That's kind of one of the big downsides to it. It'll get fixed eventually. Another difficult thing with GCP, specifically with Terraform, was lack of support. AWS is way more mature than GCP. The Terraform support is rock solid. But with GCP, you're just missing certain resources. So if you want to, we had issues with like App Engine specifically. There was things with App Engine that we just couldn't do because it didn't exist in Terraform for GCP. And then there was one thing I recall was creating uptime checks. This is just like to ping your application URL. It's pretty simple, but there's no Terraform for that either. So the alternative was to just create like a Snowflake-style project. Within that Snowflake-style project, we'll eventually import a lot of these resources back into the Terraform. What's nice about Terraform is if you have already existing infrastructure, you can still import it. So there's this great command, Terraform import, that allows you to import pre-existing infrastructure into the state, which is awesome. So if you have anything that doesn't exist in Terraform yet, in terms of like, for example, like the uptime checks that didn't exist, in the future we're able to, move those into Terraform if we need to release. What ended up happening was there were a lot of these features that were supposed to come out, and the HashiCorp team was obviously backlogged, and Google wasn't releasing a lot of stuff around this. But every issue that we ended up creating a lot of issues on GitHub, and I would get entire teams to like just upload it. So you'd see all these issues specifically to like weird App Engine like firewall rules and stuff like that like not everybody would need in Terraform, but you could see specifically like 20 thumbs up on this weird issue. It's probably not good in hindsight to do that, but they figured out pretty quickly what we were doing. But we ended up giving them a lot of feedback just how GCP and Terraform were working, so that was awesome. And we ran into a lot of weird race conditions as well. Because you have to enable APIs in GCP, you end up running into issues where one API enables another one, and you basically have to have everything listed for you to not have problems. The workaround is to just enable every API. Not a good practice, but that's what we ended up having to do just because these race condition problems used to happen all the time. If you run your Terraform, what would end up happening is it enables an API, but then you have another build that runs that enables 2 more APIs, but because that's not defined in your Terraform, it'll go from enabling them to disabling them every build. So you're like in this weird loop all the time. So enabling all the APIs solves that problem, but it's not a nice solution. That's more of a Google problem than a Terraform problem, I would say. But yeah, the solution is to just enable every API. Hopefully, there's a fix for that.
Do you have any idea why they don't enable, like, I've run into the same thing where there's a baffling array of APIs
Yeah.
off by default.
Yeah, and you need them all, and
You don't need them all, because there's thousands.
There
but
are,
you
yeah.
need 34, and you don't know which 34.
yeah, and you turn on something like GKE, and then it turns on other ones. Like you need S3, not S3. You need Google's version of S3, whatever it was called. Stuff like that, yeah. And you know, you want to, if you want to use certain features, you're going to have to enable another API, especially around like monitoring and metrics. So you get this huge list of APIs basically, and that starts causing problems. So all the APIs we needed, we just ended up enabling, which I didn't like. It was kind of a hack solution, but that's that.
At least you got APIs.
Yeah, it's true.
Why
Cool.
is that bad?
Which part specifically?
Like, just enabling all the APIs you need.
So, yeah, that's actually a great question. So typically when you're doing like an infrastructure as code practice, you only want to have things there that you're actually using. So if you're kind of following that paradigm, you don't want to just have things enabled that you're not using that are just kind of there. You only want to basically have the minimum amount of things enabled. It's not necessarily bad, I would say, but if you're following that kind of paradigm, then it's not ideal. But it's not going to cause any issues.
You could disable them in the billing account if you're worried about somebody suddenly starting to use something you're not.
That's
planning.
true. Yeah, that's also a really good point. And I did mention before how we just had billing linked right away, so whenever someone launched a project, we could get going right away. So that was a neat little trick we could do by extracting billing in the modules, so people didn't have to worry about those operational concerns around managing billing.
You mentioned security, how much that depends on the underlying cloud platform. You can set up security for Google and have it the same for AWS or Azure?
Yeah, so it's different. So how Google does it is they have these service accounts. Their IAM is a bit different. You would effectively have to have a different type of Terraform configuration between the two cloud providers. It's not quite the same. There's different resources. But AWS and GCP do follow a different kind of security paradigm. But how we were doing it with Vault, we could have easily been able to generate AWS credentials if we were using AWS. There's a way to do that as well. But there are underlying differences between the cloud providers that you do need to keep in mind if you're going to work with multiple cloud providers in Terraform. This was specifically GCP, so we didn't have that problem with AWS. But that easily could become a problem if you're like a hybrid cloud organization. So it's getting
So related to the APIs enabling, so one of the problems I kept running into was mystery quotas.
oh yeah.
So there's a lot of quotas, and
Oh,
they're
yeah.
very, very fine grained. The number of SSDs in Montreal Zone 3 quota you've exceeded.
Yep.
Does Terraform tell you before you're kind of hack committed and broken, or?
So, okay, that's a great question. If you were to run, so there's two commands in Terraform. Terraform plan, which basically does a dry run, and Terraform apply, which actually applies those changes. 100% in the apply stage, if you hit an API limit, it should come back with some sort of error.
But does it unwind, or are you half configured?
No, it won't continue. It'll stop right there.
Yeah, but does
But it
it
doesn't
roll
unwind,
back
right?
what it did?
Oh, no, you'll be no, you're right. You'll be like halfway. It'll get to that point, and then you'll have that issue where you hit that API limit. Regarding limits, I did run into that problem. It's very interesting. I remember talking to Google about managing limits within Terraform. I don't remember where that conversation went, but I remember running into those problems, and it certainly is an issue. And AWS has this as well, where you kind of have to contact support to increase a limit. You can't really have that defined anywhere. So if you run into that kind of chicken and egg problem where you kind of have to increase the limit, but you're not able to kind of track how that's all configured, hopefully one day there's a better way to handle that. Cool. In terms of rolling back, what you could do is you could just remove that Terraform configuration that you've defined, and next time you run it, it should delete what it created. So that's kind of the best way to do it, I would say. So I was going to do a bit of a demo just on AWS because setting up GCPs takes too long. So I have some code here that I've created. Just go over there, and see this. Is that clear? Does it need to be enhanced? Good. Awesome. So in terms of what Terraform actually looks like, so I created some just simple Terraform to launch an instance, an auto-scaling group, some launch configuration, security groups, a load balancer, and what else am I doing here? That's about it. And it's going to be running end-to-end. So I just wanted to show kind of what this looks like, and I'll walk through it. This first part here talks about the Terraform state, and we're pointing it to S3, and I was talking about how it makes it easier to collaborate when you have a remote state set. If you have state set in the local Git repository, you can run into issues, especially if you're running it locally, because you run into race condition problems. Ideally, if you're working with more than one person, you want to use a CI/CD pipeline with Terraform, unless you're really working beside each other and you know what you're doing at all times. You can define a provider, and a provider is like AWS, GCP. There's a whole bunch of providers out there. If you see Terraform, you'd be surprised at how much exists.
What does the provider actually do?
So that will import all of the resources. This will be a resource, specifically to working with AWS. So that's just a library, essentially. And Terraform will just reach out to the AWS API. This is all just abstracted, and then Terraform will call the API and figure all that out. You're just writing it in this, what's called HCL, which is a configuration language that HashiCorp released. Some people love it, some people hate it. I think it's all right.
So if you were to do this on GCP instead, what would change in an AWS instance?
You just make it Google,
Okay.
provider Google. And then instead of AWS instance, it would be like GCE, for instance, you can.
The majority of the fields would be the same.
Yeah, pretty much, yeah. A lot of it will be the same. Like, if you really work with AWS a lot and you saw GCP Terraform, you could figure it out right away. I didn't know any GCP, and I was already like launching stuff right away within it. Cool. So moving on, there's this data block right here. This is what's called a filter in Terraform. What a filter does is it reaches out to the Amazon API and then stores that value. The reason I'm doing this is because within the auto-scaling groups, I want to have it launch instances in all availability zones. And if a new region comes out, or sorry, not a new region, a new availability zone comes out from Amazon, next time you run Terraform, it's going to know, because it's going to update that filter value. So you don't need to keep track of any of this stuff. It figures that out. So moving on, creating a resource, you can do it pretty simple. It's pretty simple. This part specifically is just creating an EC2 instance. I mean, if anyone's worked with AWS, this is all familiar. Tags, instance type. A lot of this is just defining my variables file to clean it up. Stuff like that.
Going back to Kyle's question, so if
Yeah.
you wanted to make this file bilingual, what would you do? Like you've got something called AWS instance, that's just a name you picked, but
Yeah.
the fields like AMI is specific
Yeah.
to.
So
Is there like an if def or like how does it work?
no, so a lot of those fields will be the same between GCP and AWS.
Yeah.
Like it won't be 100% the same. Like you still have to go into the docs and see what that code looks like. I can show you after. I can.
But
show
effectively you'd fork this file and have a separate one for
yeah,
each
you can
environment?
have a separate one for GCP. Yeah,
You can or you would.
you would. You have to. Yeah, you can't. So yeah, that's a good question. So this resource specifically is to just launch an AWS instance. If you want to launch a GCP instance, you'll have to have a separate resource that defines that GCP instance, and then that'll launch that. There are some. I think HashiCorp has a tool that is geared around doing hybrid cloud stuff, where you kind of just define it. I can't remember the name. Maybe it's Nomad or something along those lines, where you can start doing stuff that's hybrid cloud. Terraform specifically, you'd have to define it, but it wouldn't be hard to add something to GCP as well.
Do you
Cool.
have optional resources?
What do you mean by that?
Let's say if the AWS data is loaded, create the AWS resources. If the GCP data is loaded, create the GCP resources.
So there's no conditionals like that in Terraform right now. This is where that Go templating stuff came from, being able to do stuff like that. Ideally, in a later Terraform version, you can do more stuff like that. Terraform is a very simple tool. It's good at what it does. It specifically solves that infrastructure as code problem. I know with configuration management tools like Ansible, you can start doing a lot of if statements and stuff like that. You cannot do that in Terraform right now. Cool. So moving on, defining a security group. Pretty simple, nothing crazy here. I'm just opening up 80 and 22. And then I'm creating a launch configuration here. And then after that, I'm creating an auto-scaling group here, and then a security group for the ELB. It's a lot of code, actually. I'll talk about how to minimize some of this. So this part here will be the security group for the ELB. So we're opening up 480, and then egress, we're going to have everything open. And then we're actually defining this ELB resource, all the health checks, everything you require, availability zone, stuff like that. And then we're just going to make an attachment to launch basically that instance that we're creating at the beginning. We want to attach that to the ELB. And I'm just doing that for purpose of demo. But this is 125 lines of code. It's kind of messy. There's ways to make this a lot cleaner that I'm going to talk about, but for the sake of the demo, let's actually run some commands. So Terraform plan, hopefully everything works because we're doing the demo. Great, so you run Terraform plan, that's that dry run I was talking about. So you see a whole bunch of stuff here. You have your auto scaling group, you have your ELB, you have your attachment to the ELB, the instance, and you have all these values. Everything is there. So it's at the end here, it's going to say 7 resources to add. So it's going to create all these things. If we do something like Terraform apply, and this will take a second probably. All right, here we go. All right, so we're going to do yes. And what Terraform is going to do, it's going to start creating things. So Terraform actually knows if something relies on something else. So if you want to launch something, but you have code defined above it, like it doesn't matter. Terraform will figure out what all its dependencies are for certain things. There's also a thing that came out in Terraform called depends on, where you can load specific things first. With those race conditions from Google, stuff like that, we were using depends on to solve some of those issues where one API needed to be enabled before another API for it to work, all sorts of weird stuff. But that ended up having a good use case for that, and that's a recent feature. Yeah, go ahead.
So is it running your script from the current directory or from the
Yep, so
or from the repository?
yeah, so I have the repository cloned locally, and then from the root of the repository, it's just all the Terraform configuration. So when I was talking about that mono repo, the reason that got super messy was because we had like 50 files. But if you have it on a per project basis, you can really narrow it down to have like one file specifically for GKE, one file specifically for compute instances, you know, for your image buckets, stuff like that. So great.
So there's no reason we couldn't have just ran a templating tool that produced something and then ran Terraform on that.
Oh yeah, no, totally. That's what we're doing with the Go templating stuff. We would, what we would do is we would run a Go command, and then we would run Terraform plan after. That templating would then generate all the Terraform. So we'd have a whole bunch of interpolation happening. We would take what's in the YAML file, populate the Terraform, create it, and then you would just run Terraform plan. That's a good workflow in a CI pipeline. Yeah.
So is that how you do it, or you check in the results? So the Kubernetes community has been moving away from that.
Okay.
Because they're declarative fascists. But anyway, they feel that you're supplying some information, a version of the templating tool. Maybe there's a command line argument, maybe there's an environment. And it seems like the middle ground would be you run that, but then the artifact, you commit that, and the committed version is what gets applied.
Yeah, that's a good point. So I can give you an example with, I ran into this. So you don't want to define everything in Terraform. A good example is like in GCP, they have functions as a service. So you want to have you don't want to really define a function because then you have to have the source code. You only take a zip argument or something crazy like that. If it's like this is related to an application, then you know the application should just deal with that. Another good example is using BigQuery. We would define the data set, with, but not the tables, because the tables aren't really an infrastructure concern, they're more of an application concern, especially if you want to apply migrations and stuff like that. So that's where that would come from. In terms of GKE, we would just define the cluster, and then, you know, obviously your manifest files, those would live with the application, for example. It could also live in the same repository, depending on how you want to have it set up. But yeah, there definitely comes a point where it's like, do I put this in Terraform, do I not? It really depends what you're trying to do. For Kubernetes stuff, it really depends what specifically.
So you said that Terraform can reorder the resources based on the dependencies.
Yeah.
Does it also prioritize the creation, or is it all sequential?
So that's a good question. I don't have an answer to that one. I think it does in parallel. I'm not sure. You saw how quickly it created all this. Some of it's asynchronous, so it'll go out and like ELB attack, or it won't wait for the instance to become healthy on the ELB, for example. when you're creating those dependencies, it's not gonna. So if an instance requires a security group to be created, it's gonna create that security group, and then because it's relying on a dynamic value, then it'll create the instance after that security group is created. So that's what'll end up happening there with something like that. If you're using depends on, it'll be completely synchronous, so it'll completely wait for that resource to finish and then continue forward. So we have an output here.
So did it wait for anything here, or did it just sent the API has accepted this?
Yeah.
That's what it said, right?
Yes. So it'll come back. So depending on how, it really depends on Amazon's API, because Terraform will call it Amazon's API. I've seen issues with GCP, some stuff was asynchronous, and it would say it succeeded, and then you'd run into this like weird issue where you have this like strange state in GCP. A lot of this, the reason it was so quick is just because launching an instance doesn't take that long.
Yeah,
T3 was pretty quick. Talking about outputs, so the reason there's outputs at the end here is because in Terraform you can find, it's called an output file, and these are just values coming from the state. So you can output like VPC or any sort of stuff you want, whereas this instance is long, stuff like that. This really depends what you want to do. You can get this pretty creative and start outputting some pretty cool stuff. Maybe you don't need to. Depends on what your use case is, some of that stuff. Word of caution though, figuring out what some of these values are can be a bit of a pain. You gotta go through the Terraform state. There's a great command Terraform show that actually shows, and I'll show you what that looks like as well.
So if you were to run another Terraform now,
Yeah.
does it have access to those variables from the first guy?
So now, because it's in the state, it knows that all that exists.
So if you have a second TF promise directory that you haven't run,
Yeah,
it
it's
can just
gonna-
refer to that IP.
Yeah, so, okay, what'll happen is if you run, let's say you add some more Terraform, next time you run it, it's gonna know that the rest of that stuff that was already written already exists, and it's only gonna add what you added. So let's say you want to add a bucket, for example. It's gonna add the bucket, but because everything is in the remote state, and I'll talk about the remote state, I have a slide on it, it's gonna know that it exists in the remote state and that it's locally in the TF file, and this new thing, this new bucket, for example, that will be the only thing that gets created. And I can show you an example of this, if that makes sense. Or removing something, which I was planning on doing.
How does it correct for failures? Like, for example, you launch 100 machines
Yeah.
and you do it at a busy time in AWS. Sometimes
Yeah.
you get errors
You-
that
you-
don't give you the resources you're asking.
Yeah, this can happen.
Does
Yeah.
it fix itself, or you have to run it?
You have to run it again.
Okay.
So it'll know that a few of those instances have been created, but it knows where it failed, and then you'll have to rerun it to continue basically.
Will it like start all over, or just figure out this is what happened, this is what didn't happen? Just do
Yeah.
the remainder?
Yeah, so it should just do the remainder because it puts each instance in the state. So if it launches, fails on the fourth one, it should only have to launch one more next time you run it because the other three launched successfully and they're now stored in the remote state.
Does it clearly indicate that there's a failure?
It'll come back with an error.
Like
some
not
sort of-
zero or code,
No, it'll come back with
Stack trace.
Well, so I guess
It's a-
I'm
it's a
getting
ghost
the
stack
CD,
trace,
the
actually.
CD thing, right? Like how do you automate this if it can just randomly fail without?
You have a Slack webhook that
Okay.
tells you your build failed and you look at it.
And you get used to
Unfortunately,
typing
there's no-
wild true.
Just always have it running. I mean,
Yeah.
And don't forget your sleep one.
Is it able to handle remote spot instances?
You can do spot instances, yeah.
Can it handle when they remote after?
I haven't tried that. I want to say it can. We can look at the docs after. I'm curious as well. I haven't really handled the spot instances in Terraform. Probably should have. But yeah, there's a flag within the AWS instance that asks if it's a spot, and you can do like all your spot bids and stuff like that. So it's definitely possible to do spot instances. Let's get out of here for a second. So we have that. Yeah, so great. So we had that ELB CNAME come back, and it's just running Nginx, just for the sake of the demo. Great. We have Nginx running. We have a few instances. If I go to EC2 and refresh, hopefully it doesn't want anything out. We have some stuff. So this is that demo instance I created that we eventually attached to the ELB. But there's two of these instances, Terraform-demo-ASG, that were created because we defined a minimum of 2 resources within that autoscaler. So going back to the code.
So hypothetically, if somebody else had installed something manually in this resource group, Does it reconcile and get rid of it, or what
I
do you
love that
do?
you asked that question because it does. So if someone was to go, so this is when I was talking about snowflake infrastructure. If someone goes,
It melts them.
Exactly. You have a port, someone opens some crazy port, I don't know, it doesn't matter, this is just a simple example. And that ingress is defined to only be 80 or only be 443. Terraform's like, why does this remote instance, when it collects the data about it, the metadata, have this port open? I'm just going to turn it off because it's not defined in your Terraform configuration in either in the repository or locally. So it's just going to remove that setting.
So if somebody's manually created an instance unrelated to this Terraform setup, it's going to delete the instance?
That depends. So if someone has access to launch an instance,
Yeah.
that instance will get launched in AWS. That part specifically doesn't affect Terraform. It's not an instance that Terraform was managing initially.
So everything that it thought it created or managed,
Yes.
it puts it in the state it wants
Yes,
regardless.
everything, yeah. And
But
this
other
is,
stuff in the resource group is kind of left alone.
yeah, so this is why when I was running it with GCP, we wanted to have everything in Terraform, because we wanted to keep track of everything that existed in the cloud environment. And if people are going and launching random stuff,
Yeah.
you can't keep track of that. So ideally, what you would do is you'd have IAM policies that don't allow people to launch instances, so they only can use Terraform. So you can.
But then it turns out you work for some of those people and you couldn't take it away from them.
Yeah, that's true. The way I look at Terraform is like, it's not a gatekeeper tool, it's a tool to help enable people, but also have that practice around keeping things not snowflakey, I guess, or kind of what I call cowboy cloud environments, where it's just like, everyone has admin, let's do whatever we want. Now it's kind of scoped down. And my experience with developers in Terraform is like, it's not bad if you create a bunch of great modules that have a lot of these preset values that it's just like, hey, 4 lines of code, here you go. It's in a repository, it'll run it, create it. It's just track. You want to have like a middle ground where people are still enabled to do their work, but you also have oversight into how everything is created and tracked, and you want to have some sort of life cycle management around the infrastructure. You obviously don't want to lock everything down, and it's like you have to file a change request. Like
Yeah.
you want to avoid that kind of stuff. Although banks are using Terraform specifically for that, where you launch, where you would have a change request and you would do that. So I was going to create a quick branch here. So we're talking about making a change. So let's go in here and let us close port 22. I'm just going to commit this. Yeah, one of my favorite things with Terraform is like if someone makes a change to an instance, and it's not in the Terraform, it'll just revert that change. And we're going to go to CI now because it's a perfect segue. So this will be great. So we have this as an X instance, pretty basic. We'll go back here. Next slide. Yeah, we're talking about the state. The state's remote in S3. You can have it locally, you can have it stored in, basically there's a whole bunch of different places you can have state stored. You just have to look at the Terraform docs, whatever works for you. Your desired state is what is created locally in that, or in your Git repository, in that .tf file. And then the current state is this .tf state file, which is going to live on S3. And we're talking about, someone makes a change to an instance, changes the tag, opens a port, it'll revert that change because it's not defined in the Terraform. When Terraform goes to the AWS API and sees this metadata, when it fetches that, it's going to be like, no, we're just going to remove that. So if I were to open a port, for example, easy example, it's going to change that. So running a remote state is a good idea if you want to do CI/CD with your Terraform or your infrastructure as code tool, and then store in a centralized place that fits back to that.
What's the ramification if you lose it somehow?
Don't lose it. That's why you can have buckets that are like highly available, sync to another region.
The short answer is don't.
Yeah, don't. You could, well, if you're small, I've done this before, that's why.
And don't restore the previous day's backup either.
Yeah, exactly. Because you don't know where you last were. Yeah, it's a bad idea. If you do end up, if that does end up happening, you basically have to run a whole bunch of Terraform import statements, and it becomes a pain. anyone who's used Terraform has definitely done that before, and it's not great. Not great. I did quickly want to talk about just modules. There's this great thing called Terraform Module Registry, which didn't exist for a long time, and we're all creating all these modules that are now released by official providers like Amazon and Google or HashiCorp. So we don't have to reinvent the wheel anymore with these modules. What's great about them is if you want to see what some of this Terraform module stuff looks like, a really great one is Vault. There's a Vault module on Terraform Registry that launches a HashiCorp Vault cluster, and like a few lines of code, you have this entire cluster. I know someone's going to ask about config management. You can use Terraform with a configuration management tool like Ansible, or if you want to use like init data within AWS, I forget what it's called. If you want to launch, you can provide a script to AWS when the instance launches within the Terraform. So that shows Cloud. Thank you. And you can do that kind of stuff. So there's a whole bunch of interesting stuff on the module registry, so you don't have to create this stuff yourself.
Do you know, are the modules written in HCL or whatever it is, or is
Yes.
it, okay.
Yeah, and some of them get crazy. So what you saw with what I wrote with the autoscaler and all that stuff, that can all be a module. Plus you can have a database in there, and you can have it like default set to highly available mode, all that kind of stuff, so it meets some sort of compliance that you have in terms of like what you want your infrastructure, how you want your infrastructure to be set up. And then a developer can take that in like a few lines of code, have like a pretty beefed up environment. Stuff I've done in the past with AWS is like we've created, event deployment tool, I don't remember what it's called, it deploys artifact, set some of that stuff up within Terraform as well, so you kind of get this giant environment set up within the Terraform. And you can make this all modules if you want to share it among different teams, and you can version these modules, so if you make a change to the module, and it's potentially a breakthrough change, you don't have to release that out to everybody in that module version. Using modules is as easy as referencing a SSH URL, or you can use one of these versions, which now exists, which is great. Cool. All right, let's talk about Jenkins, and that's honestly how I feel about Jenkins. But for the sake of this demo, and because I've used Jenkins a lot, I'm going to show you what running Terraform with Jenkins looks like. So back to that change I made. So, and all this code, if anyone's interested, is on my GitHub. So we created this branch, security-group. Hopefully this works, and Jenkins will crash. So we're just commenting out core 22. So we're going to create this pull request. I configured this with multi-pipeline configuration. There's this thing in Jenkins too that defines this code that you can do. I don't want to talk too much about it, but I have the pipeline defined, and if you want to take a look at it, make changes to it or use it for yourself, by all means. Great. So right here you can see 2 checks have passed. My picture shows up because I used my API key, not a good practice. So if we go to Jenkins, this really bad Jenkins server.
So those checks are like linked type things?
So those checks would be the build pass, and then it sends a check to GitHub saying that they're passed. So specifically when you're running Terraform in a pipeline, you want to make it so you can't merge your code until the build passes.
But effectively it's like linked, right? It's statically checking that it's valid?
Yeah, so I'll show you the pipeline in a second, but it's running that plan against Terraform. And I'll talk more about like Terraform testing and linting, and if anyone's interested. I think it's pretty cool. All right, so in this Terraform demo, it's really slow. There should be a pull request here. All right, PR number 5. So I was doing stuff earlier, obviously. So this is what it looks like. So you have your checkout stage, your init stage, and then your plan stage. The init is to just initialize the state and handle that part. So build pass that I created in GitHub. And so let's scroll down. Here we go. So Terraform now says there's one thing to change. This is not very readable, but once you start looking at Terraform, you kind of understand what it's trying to do. One line here, specifically that stands out, is this. So if you remember, we removed port 22. What that's going to do is it's going to just get rid of port 22 here. So we can see that like 80 is still staying, and everything on the right side is basically what's going to change, and a lot of it's the same. And then you can see this port 22 is going to get closed.
So this Jenkins job has RBAC access both to the remote state storage and also to your AWS.
Yeah. So it
So
has,
it's you.
this is me specifically, yeah. But if you were to want to have it, you have some sort of robot account.
Yeah.
For the sake of this demo, it's just me now. But yeah, you want to have it be like a bot account. Great, awesome. So let's actually merge the pull request, and then I'll show you what the pipeline actually looks like. So we'll merge that. We'll pretend I didn't do that. We'll delete that branch.
That way you'll never know.
Yeah, I'm the admin. So we can see masters running now. So this is all based on webhooks.
So we laugh about that, but what do you do when somebody's done a forced push? And now you're screwed because your history's been rewritten, but it's also physically in something.
Great question.
Don't do that?
We were using branch protection, stuff like that.
So the short answer is don't do that, right?
Don't do that. Don't do that, exactly. And hopefully you're not a large team that has a mono repo of Terraform like I was talking about before, where something like that can happen.
So is the flip side of that a rebase workflow isn't a good idea for this?
So that's a good question. I've run into issues where with Git specifically in Terraform, it'll just want to delete everything. With Jenkins, if you don't define like a clean workspace, for example, you start getting all these weird issues with Git, potentially because you're constantly cloning, and eventually you have some sort of issue with Git, and then it'll just want to delete everything. So an alternative would be to clear the workspace, for example. Rebasing should be fine, as long as you're not pushing it into master. That's what's going on. But the whole point of that code review process and then running it just against the pull request is to see what the outcome is with Terraform and how Terraform responds to some of that stuff. Great, so we can see a lot of this applied. And let's just go here. Security groups. There we go. So it's gone now. So let's do that change where we add some weird, let's do like a Ruby or something. Something. This one came into my mind. We'll do this locally just because. At that point. And I'll go over the Jenkins file what that looks like. So you can see that it's going to remove that NDA now because you added that in manually. I can do Terraform fire, it doesn't matter. There's just like -s flag in CI, just for anyone that tries that out. So it got added to the Terraform version. So we'll do that, and then we'll go and while that runs, we'll go to the Jenkins file. So this is what the Jenkins file looks like. It's pretty simple. It's just like a try-catch block. If anyone's worked with Jenkins pipeline, it's just groovy. It's pretty simple. You do a checkout stage that cleans the workspace, checks out the source code, so there's no weirdness with the state Terraform. There's this init stage where that deals with the state. It sets up Terraform. I don't like this, but there's this CloudBees AWS Jenkins plugin, and I have to reference this as a class because there's no like native support for that plugin within a Jenkins pipeline, unfortunately. So I had to go through the depths of the internet basically to find how to use this credential binding thing for AWS.
So then you have your credentials as environment variables.
So they're
and
stored.
This branch is protected so people can't push a echo variable to it?
Yeah. So it's also stored as a Jenkins secret.
Okay.
So that's how this works. It's stored as a Jenkins secret, and then.
But effectively, that's your protection. Is you watch pull requests against the Jenkins file
Yeah.
to make sure somebody doesn't add an echo that.
Yeah. Even if you. Yeah. Exactly. We're going to just do right here, it's just a simple plan step. Again, you have to define the credentials. I don't like how that looks. And then I just added some terminal colors to make it look nicer. And then if the branch is master, then run the apply. We don't run the apply on the branch or the PR because then like we can just.
You still run the plan?
You run the plan, but that's just the driver.
That's just checking to make sure it's valid.
Exactly. Make sure the Terraform's valid. And then once it's passing and it gets reviewed and the checks pass, then you can merge it and then it'll run the Terraform apply. And then at the end, I was going to show the Terraform show actually. It does it here in the build, but I'll show you what that looks like quickly. take a second. And these are all the values from the state, basically. And so if you want to like figure out an output, for example, look at this thing. It's got a whole bunch of metadata about the instances and the ELB and everything you basically create.
So if the plan fails,
Yeah.
where in the Jenkins file would it say stop, or it doesn't?
It's
Or is that someplace else?
yeah, no, that's it's just down here. There's a try catch block. So if it fails, Jenkins will mark
Oh, I
it.
see.
Yeah. So down in this. Oops. What was that? Just this part here. Cool. Don't have any questions about the Jenkins stuff. This is all in GitHub, so if anyone wants to play around with this Jenkins file for themselves and with Terraform and Jenkins, by all means.
So what do you think a best practice workflow is? So you're presenting a model, the kind of nirvana where people make a bunch of changes on branches, smart people review it, it gets merged to master,
Yeah.
master's well protected, whatever's on master, the CI does CD for it.
Mhm.
But Jenkins has been known to be imperfectly reliable. So you just eyeball and watch. So the person who runs the pull request, it's their job to watch the job to make sure that it goes live, or do you run a Terraform apply every hour to sweep up changes that might have gotten missed, or?
Yeah, that's a good point. Ideally, the developer, once they create that pull request, you'll get a slide. This doesn't have any sort of notifications. I didn't configure that, but hopefully the build passes or it fails, you'll get a notification for it. And then whoever reviews Terraform pull requests will then look at it, make sure it's good, and then merge it. Ideally, you'll have more than one person look at it potentially, but that's kind of the overhead of introducing something like infrastructure as code, is that you should have someone at least take a look at some of this stuff, because you do want to make the infrastructure portion also collaborative. I don't recommend some sort of trunk-based Terraform development. I've tried it; it doesn't work so well.
I think Don's question was more about what happens if master fails.
Oh,
Like let's say that Jenkins has a Jenkins-related problem.
okay.
Maybe the Terraform is well formed,
Yeah.
but you ran it on a preemptible node and it got eaten or something. Like,
Right.
whose job is it to make sure that it actually got live?
I would say, yeah, so whoever is reviewing changes for Terraform, I guess, either most likely that tech lead of that team, let's say, is going to be responsible for making sure that Terraform runs.
So there's a similar thing for Kubernetes called GitOps.
Okay.
And this company Weaveworks, they created this thing called KubeDiff.
Mhm.
And what it does is it just sits all the time and watches your Git
Yeah.
and looks at what's live and it stitches if they're ever different.
Yep.
And then it catches things where your CD thing crashed due to unrelated reasons. So
Yeah, I looked at using like Probot and stuff like that to make some of that workflow stuff better. But yeah, that's a great point. You can definitely improve some of this. This is just like a bare basic.
You can just run Terraform and just compare. And if you get outdated in like
Yeah, you
the
can
last
always
15 minutes, you can just align.
Yeah, you can do that too if you want. Like it's easy to just write scripts that do this for sure. Hopefully that answers the question.
The Terraform output, the Terraform plan output that shows, that's human readable. Is there a machine readable version of that? Like, can it output JSON or anything that can be parsed according to it?
I think there's a. Let's actually find out.
that's machine readable. We could all write a bash script to do that. Come on. We all have written a bash script. Maybe 7.
Oh, so we were talking about to parallelizing, and I just found that's a flag. So I guess not.
I'm sure there is.
So in the plan, there's no specific flag for this. There is something called, there's this company called Gruntwork that releases a whole bunch of Terraform stuff, and they created like a wrapper above the Terraform CLI, and that adds some extra capabilities, so perhaps that might have it. The name escapes me right now, but it's possible that that could solve that problem. I'll get the name of that for you. Cool. There was a lot of questions, but does anyone have any other questions? Yeah.
Can I ask the beginner question?
Go ahead.
I don't, so there's Ansible and
Yep.
Chef and Puppet and their friends.
Yep.
There's like in Amazon, you can have like auto-scaling groups or whatever, so that you can scale up to 1 million instances.
Yeah.
And there's this Terraform,
Mhm.
and I don't understand really what the difference is and what niche each of them has.
Great question. So configuration management tools are great for doing configuration management. Terraform is not a configuration management tool. A lot of people have made that point, like Terraform versus Ansible versus something else. They're actually not competing with each other. They all kind of work better together.
What is the competitor to Terraform?
Google's infrastructure as code tool, Amazon has one that escapes me what it's called. Yeah, that one. But I looked at it once and didn't want to use it. That's what they compete with.
So there isn't another multi-cloud?
Not that I know of. I'm sure there probably is. That I don't
The thing
know
is that a lot of them are platform lock-ins. So for example,
Yeah.
you choose CloudFormation,
Yeah.
that's it. All of the code you generate from CloudFormation will work great with Amazon, but you can't take it over.
I'm glad you said that. And that's the reason.
So maybe Cloud Foundry or like Cloud Bees, one of those guys, they have cloud neutral.
Yeah, the reason I use Terraform is because of what you said right now, is that you have this infrastructure as code that a team has to learn specifically for that platform. The second you use another platform, you got to learn some other tool. If you standardize on something like Terraform, you know Terraform, you can use it for any cloud provider type of thing. So it makes that part of it easier.
So what is it about Terraform that makes it actually, what is it abstracting from the cloud providers' individual offerings
Yeah.
that makes it useful? Because I mean, you still have to understand how their APIs work. To some extent, you need to understand how they're modeled so you can model the resources in
No,
Terraform.
that's a great question. Terraform has a very low learning curve generally, so it is easy to use. In terms of other tools, Google specific infrastructure as code tool, I've looked at using that specifically for GCP. There's no state. And the biggest benefit of Terraform is that state file. Being able to track the lifecycle of infrastructure and the history of it and all of that stuff is a big benefit to using Terraform. This is just a tool that solves that problem right now. There might be something that comes out that's better, but
So would it be fair to say that one of the benefits it gives them is you can sort of basically have the same workflow regardless of the platform you're targeting?
yeah, well, that's definitely.
So then people would use configuration management after Terraform has run.
So
And then they would use the elastic auto-scaling. So Terraform's running once, the elastic auto-scaling is running continuously, and therefore Cloud Init would be driving Ansible continuously.
you could do that. Another practice in this kind of HashiCorp ecosystem is using Packer. You can use
Yeah.
Packer with Ansible to provision that stuff and then publish that.
Yeah, that's just really just the pre-configured versus
Yeah.
post-configured.
Yeah.
You can also use the Terraform module in Amazon to have it initialize or update the infrastructure.
Well, I was thinking about the auto-scaling because Terraform's not running.
So what you can do, and I've done this in the past, is when I was talking about those filters, what I was doing was I was creating AMIs all the time, updated AMIs. With Terraform, you can define a filter where you define to look for that AMI, and you can sort by the latest one that gets published by that name. So let's say you have an AMI that you publish that you want to use within Terraform or the autoscaler. Terraform will go and run that filter against the API, figure out what the latest one that was created was, and use that. That's how it
Were you
works.
happy with using latest, or did you eventually turn into pinning?
Well, it depends what your workflow is.
If your workflow
That's
is
a
being
good-
unhappy once in a while late at night when you're not expecting it,
Yeah, that's
latest is a good way to go.
yeah, definitely. Like, you could do it if you wanted to like that, for example. Or you could just update that AMI value, and then the scaler would then use that new AMI and then just delete everything and recreate the instances. Because if you define a new AMI, it's going to want to delete the old instances and create new ones. So that's also another way to do it. There's plenty of tutorials on like rolling deployments of infrastructure with Terraform, so you can do that. There's a whole bunch of different ways to do that for sure.
How you compare this with Azure infrastructure as code?
Never used it. I probably should take a look. I did hear about that recently, so I'll get back to you soon with an answer to that. But yeah, each cloud provider has their own kind of infrastructure as code specifically for that cloud provider, but if you start using multiple cloud providers, it helps to standardize.
Because Microsoft is selling this like make it easy or something, so it's really interesting to compare it with Terraform and see.
Yeah. Vendor lock-in isn't a problem, or you're specifically on one cloud provider. Like I don't see the downside to using the cloud-specific infrastructure as code. It makes total sense. Another good use case for Terraform is, you said someone who's using it on-prem for certain stuff, like there's a whole bunch of different resources with Terraform. You can do all sorts of crazy stuff with it. One of my favorites is Google's DNS. It's like, you want a new DNS record, just make a pull request to this repository, and there you go, it's done. And it's audited and tracked that way. That's a simple use case or something like that. There's so many resources for AWS in Terraform that you can basically find anything within Terraform. So you can start doing things that aren't even infrastructure, like doing Route 53 or other sorts of stuff, networking, and the options are endless with that stuff. Yeah.
Yeah, but now, so I'm still not clear on, so let's say I'm a dinosaur and I'm spinning a virtual machine.
Yep.
The configuration management says, in this virtual machine, set this file and set this file and install
Yep.
this program. And Terraform is saying, make the virtual machine.
So Terraform is just launching it. If you want to run configuration management inside of it, that's completely separate. Like you can do that.
So then what?
So the
What
benefit,
were you talking about before then when you were saying that you can use Terraform with Ansible? Like what?
so if you want to launch the instance with Terraform and then provision it with Ansible, like that's totally fine. So Terraform is just launching and managing the infrastructure. It's not configuring software on the VM, for example. Like that's what a configuration management tool is for. Specifically something like Ansible. Terraform's job is just one thing: launch infrastructure, manage the infrastructure settings, but the application is obviously separate, and then software installed on that VM is
So
separate.
what this is automating is I don't have to go to the AWS
Exactly.
web console.
Yeah, and if you want to launch like 100 instances or something like that, or you have like with modules and you want to have certain abstracted settings from developers, you want to follow a certain paradigm, it's supposed to just save time. Is essentially makes your life easier as an operator, makes the developer's life easier because well they can launch all this infrastructure that's configured correctly, and it's using the right instance type. But
I think the idea is you're doing it declaratively. So you say, I want this,
Mhm.
and then it goes to the API and does it for you.
And it does.
Rather than you saying, do this, then this, then this, then this, and this.
And also there's
But I
that-
mean, this is the sort of thing that you would do by hand,
Yes.
Yeah.
like by
Yeah,
putting
exactly.
stuff on.
And it also has that state that tracks the life cycle of that infrastructure and all that stuff.
So can you destroy things with it?
Oh, yeah, let's do that right now,
I
actually.
bet you almost can't.
I was waiting, I almost forgot about this. Let's just destroy everything.
Could we destroy stuff with a typo?
No.
Really? You commented out of block?
So no, that'll work, but if you change, like, if there's an error in the Terraform DSL, no. If you change the name of something, yeah, you can do it. So you can see here, I ran Terraform destroy, it's going to delete all this. Obviously, you could do this by just commenting it all out and doing it in the CI pipeline, but for the sake of this, let's just destroy it.
What's the scope of that destruction?
So,
It's some two things in AWS?
yeah. It'll just reach out to the API and destroy that specific infrastructure, but it's going to wait to make sure, like it's doing it in a certain order. You can see here.
Does it destroy
But that's-
what's in the current state, or what you've defined in the bot in the config?
What's in the so that's also another great question. So it's gonna destroy what's in the current state.
Okay.
So if you run it,
What's in the state file?
yeah. So what's in the remote state file? It's gonna destroy all that. If you have that defined here, it's gonna destroy all this stuff because that's what's
How would you handle a case, like you mentioned Route 53, so one of the things that I've been struggling with Kubernetes is the delete is actually a big deal because it doesn't have state. And when you go to reconcile something, you end up with orphans. You mentioned configuring things that are kind of outside the scope, so a domain name with Route 53. Would you ever have the case where you had something you created with it that you didn't want to delete?
So you have a resource you want to.
So let's say you define 10 things in here,
Yep.
but one of them you say, by the way, when I delete, I don't want it to go away.
So you want to delete it from the Terraform state.
Well, maybe not. So Kubernetes has this concept called a permanent volume claim. And with one of its config tools, Helm, it's
Yep.
relatively common for people to Helm install X.
Yeah.
By the way, the PVC will live if I do Helm delete X.
Okay.
And that allows them to delete it and install a new one later and it reclaims it.
Yeah.
But a domain name is another example where, or maybe an SSL certificate, you're going to Let's Encrypt,
Yeah.
you're only allowed 5 of the same thing a week. You don't want to be doing it again and again and again.
Right.
So maybe you say, this one's a snowflake.
Yeah. So one quick thing that comes to mind is if you want to delete stuff, but you want it to continue existing, you can remove it from the state. So there's this state RM command. Don't ever use it. Where you can basically do Terraform state RM, the resource name, and then the value. And
So you can hack it out of the thing.
Yeah.
So I think the use case here is really like, it's like, you know, I've completely screwed something up. I want to start from scratch, but I have some state in this state store that I don't want to go away.
Yeah.
With some of the tools Don and I have been working with, it's kind of hard to have separate things linked together, so you just put them all together into one big blob, which means they're very, they're modular and abstract from one. You can't apply one and then the other and then delete the one without deleting everything. With Terraform, it's easy to separate stuff that way, so you have your DNS records separate from your main application.
Yep. Yep. So you have multiple states. When I was talking about the Google stuff, every team had its own project. It's just in that use case specifically, if they wanted a DNS record within that project, it would be the same. But I've seen workflows where it's like, good example. Something I did previously was we had like a VPC specific repository that just was handling VPC stuff for Terraform. And you could even narrow it down even more. It really depends how you want to do it and how modular you want it. Like you could have one repository just DNS records, one just VPC.
But can two Terraform state files refer to each other? So, like your example here created a public IP.
Yeah.
Could you have one Terraform state file that created that, and then another one that just automatically referred to that by variable name without configuring in the IP?
So it's going to say, that's a good question. When you run Terraform init and you're referencing a pre-existing state, it's going to tell you.
But from a different TF file.
Yeah. So if I was to create a new TF file with a new state definition pointing to an existing state, it's going to be like, this state is already existing. Do you want to copy it over?
Well, I'm thinking more like a shared, it's like, let's say this load balancer, there's 5 of us sharing it, and we've each got a vhost routing rule. So none of us want to delete it. Would you use Terraform to create that in the first place and then we all reference it? Or with each of our TF files, we just target OJ 100.10?
Yeah, you can reference that kind of stuff.
Okay.
So there's a...
So I can refer to somebody else's state file?
No, only... So if you have the state defined, specifically, like in this example, go back. So you have the state defined here. This is the state you're referencing, that's it.
Okay.
If you have like a value, like an ELB IP that you want to reference, you can do it, like through dynamic value, and not hard code. An example I have here is like,
So where does that come from?
so this value, this AWS underscore security underscore group demo.id is referencing this resource called AWS security group. Demo is the name, and then ID is what gets generated in the state. That's that output I was showing you. And then it would reference it here, for example. But this is in the same state. It's not in a separate state. I haven't played around with trying to manage multiple states, so that's kind of the extent of what I've been doing. Yeah.
I guess on that note, if you make something and give multiple customers and you want to use that entire, how does it play with that?
Yeah, so you're talking about you want to have reusable components?
Yeah, so it's like multiple instances of this whole setup.
Yeah, so you have a module, basically. That module would be a definition of what you want that instance to look like, how many of them you want, and then you can just define that module within separate places.
So am I calling Terraform once for each customer? Or do I have a big file that defines all customers?
Don't do that. If you have customers, probably good to separate out each Terraform, but if you have top-level modules that have a whole bunch of preset configurations that you don't want to keep writing, think of like dry. Don't repeat yourself. You can have this base module in that module.
Imagine what I meant, like, so if I commit a change to one layer, where do I write a for loop for each customer?
No.
Terraform, or what
No.
what
So-
do I think of that?
So in your repository, you want to launch instances. For example, you can reference a module, that module will launch some instances. But if you have separate customers, that separate customer, those instances you want to launch for separate customers will be in a different Git repository, for example. But you'll have to run Terraform each time, if that's what you're asking. So you have to run Terraform 2 different times, but you have 2 separate states, if that makes sense.
So what's
So they're
the
sharing
practice
one.
is like to have a Git repo where every customer is listed and you add them and delete them.
No, so a practice,
Sorry.
yeah. Do you have like a use case that you're trying to like work with so I can get a better understanding?
So if you got a software as a service,
Yeah.
so you give each customer an instance of it,
Yeah.
and you get a new customer, and now you've got 100 customers and it's 100 virtual machines.
Okay.
And
I see what you're saying. So you're talking about like on-prem deployments,
well, cloud,
cloud, but you have,
but
okay,
they're not sharing. We're not sharing servers.
right. Yeah, okay, so that really depends on how you want it set up. Like if it's all within the same AWS account, for example, what you could do is you could have a module that launches an instance that isolates all the networking for each one, and then those would talk to each other. And you could have that all defined in one Terraform file. If you want to make a change, let's say to all of them, you could make a change within the module, and if you have it versioned, you can increase the version, and then you can propagate that change to all those customers, for example. Does that make sense? Maybe we can talk about it more after if you want to hear about it.
I guess it'd be a parameter somewhere in the Terraform
Yeah.
file that says tells you which state you're talking about when you call it.
Yeah, if you have a repository with all your customers in it, that'll be one state. If you have modules are separate, they're just a way to abstract resources to make them easier to work with. And then if you want to make a change to like 50 instances that are referencing a specific module, you could just make a change in the module as opposed to each instance.
So do you
That's
make
like
the change in the module and then explicitly run the pipeline on each instance?
Yeah, so next time you run Terraform plan, if you have, so you'll have kind of pin, so let's say you increase the version, the next time you run Terraform plan, it's going to show all of those changes. Because now you can see that what it's referencing now in that state in the repo is not in the original state. So going back to that.
Does Terraform enforce any sort of mutual exclusion? Let's say I run a plan or run a apply.
Yeah.
Let's say the ultimate goal is to create this one resource that depends on the dozen other.
Yeah.
And halfway through, Don comes in and says, Terraform delete.
Sure.
I think that's in the category of don't do that as well.
So when you work with Terraform with a whole bunch of people, you want to prevent people from mucking around with the CLI tool because really you can change anything.
Even in Jenkins, like one of the problems I've run into in GitLab with ours,
Yeah.
with SIM architecture, is the jobs are farmed out in parallel across a lot of things. The job that was submitted first doesn't necessarily end first, which is funny. But
Yes.
it's not funny when it has an output like this.
Yeah, I've run into that race condition kind of issue with Google's running Terraform in Google, where it'll create some sort of asynchronous request. It'll say it passed, but when you look at it,
But I mean, you could have it in your Jenkins, like you've got 2 Jenkins runners.
yeah,
You could do one push to master,
Yeah.
which starts a job, and then another push to master 5 minutes later, and that one might finish first, and then the first one
oh, I
runs.
see what you're saying.
Will Jenkins run jobs in parallel, or does it wait for the previous one? to
So
finish to finish?
what
can't
I remember now what we did with this, because we did run into this problem. Funny enough,
You
where we
decided
were
to
running a
not
whole
do
bunch
that?
of builds. Yeah, no, we would
There's a big
basically-
hourglass beside the merge button.
Yeah, there's a plugin in Jenkins that will you can reference it in your pipeline. I can't remember what it's called. It's escaping me
But
now.
it's a mutex of some sort.
Yeah, it's a mutex, exactly. So you would make sure that build has to finish first.
Okay.
Before we ran into issues, I've run into issues
Yeah.
with that where like we're running database changes to database, and it's like, oh, this ran before this
Okay.
one, or this one got queued and it never ran because Jenkins sucks. That'll happen a lot. So then you have to do that mutual exclusion, and then Jenkins problems are different than Terraform problems, that's for sure.
Yeah.
We did end up using Circle CI for, we moved off of Jenkins when I was working at Tells. We ended up using Circle CI, which is just a lot better for some of that stuff. It ended up working out better, but it just knows Jenkins so well that I just broke that up quickly.
Cool.
Awesome.
Well, it seems like the crowd enjoyed the Terraform. Thanks very much.
Well, thank you.
I think they've even saved a couple of pieces of pizza for a speaker.
Where can we find the example?
Oh,
Is it
let me plug it in.
GitHub or?
GitHub Scalar software.
Yes, it is.
Scalar software, okay.
Right up on the links, if it plugs in.
And
Right here.
more question.
Yeah.
If I use CloudFormation right now, are there any limitations or particular things I should be aware of if I instead start writing Terraform?
I don't know CloudFormation well enough to give you an answer to that. I kind of looked at it once and that
They
was
kind of
that.
ignore, they kind of ignore each other. Like
Because
they're-
CloudFormation's
I
used to
don't
like
know if
launch
it-
instances, right?
It keeps state, like it's like a heap template.
yeah.
Right.
So Heat actually came from CloudFormation, but and Terraform is the same. They're all the same technologies, but they don't even operate.
Yeah.
I think what they were asking for is like, is there anything that will prevent you from migrating from CloudFormation to Terraform?
You just have to
It-
rewrite
it-
it.
It's Terraform feature complete with CloudFormation.
Yeah, you would have to, if you're talking about moving from CloudFormation to Terraform, you'd have to, you can leave all of those instances running. What you could do is you could import them into Terraform. Yeah, so hopefully that's the answer you're looking for. There's these Terraform.
Actually, I like that answer.
There is one key set of differences, is that the CloudFormation has a set of lifecycle hooks and so on that aren't, like, it's intended to be something that can run all the time and run as a game.
The only downside with importing with Terraform right now is that you need to know how your infrastructure is set up and you need to write that Terraform. In future versions of Terraform, they're thinking of creating a way to do an automatic import where it writes the code for you. So wait for that, and then that'll probably make, if you have like a lot of,
Importing will tell me the diff between whatever.
yeah,
blank
it'll
template I
automatically
have
figure
that's
out
there.
how the instances define and then spit out that Terraform configuration for you, and that should make that a less important. When it came to importing stuff into Terraform, if you have a lot, it can become a pain. So I used to like write just scripts, bash scripts or whatever that would just mass import a whole bunch of resources. Like I've done that before. It is possible, but doing it one by one can take a long time depending on how much infrastructure you have.
So let's say you do have a lot of infrastructure at the end, you keep like one big Terraform configuration file, or do you split it
You
out?
can split it up. Yeah, so
Like
you can have multiple states. If you want to, let's say, split it up so Route 53 is in its own repository, you can just import the Route 53 stuff in one place and then instances in another place. It really, there's no right answer here. It really depends on how you want to work with it.
Do you have like a best practices? Like, for example, things
Yeah.
like VPCs, it's like, it's the first thing you want to set up or the last thing you want to delete.
It depends on your organization. So if you have really complex VPC setups and you have a team that really wants control over something like that, I would say split it out. If you just want to define a new VPC for the instance, specifically for that instance, you can always use it with the instance Terraform, like launch it in there. It's hard to answer that question. Like it's different for everybody. And there's no real right answer to that. It really is just like, how do you want to work with Terraform? How is your organization set up? And then model it based on that. Cool. Well, thank you, everybody.
Thank you.